Oscar Piastri just made a statement that shook McLaren's headquarters to its core. Mark Webber backed him up and insiders are calling it the biggest internal crisis since 2007. New 2026 simulator data just leaked, and it's so bad, the team may need to rebuild their entire concept. The drivers are worried. The engineers are divided. And the clock is ticking. Subscribe now because what's happening inside McLaren could change the entire 2026 F1 grid. Just as McLaren was gaining momentum in the 2025 development cycle, a public statement from Oscar Piastri sent shockwaves through the entire paddock. In an unusually candid interview, Piastri questioned the direction of the 2026 car project not just in terms of performance, but in fundamental concept. He hinted at internal disagreements, data irregularities, and simulator results that had genuinely alarmed both him and his race engineers. For a young driver known for being composed and diplomatic, this was a clear red flag. What made the moment even more dramatic was the backing he received from Mark Webber. Not only Piastri's manager, but a respected former F1 driver and paddock insider, Webber confirmed that concerns had been raised directly with senior leadership at McLaren. He didn't mince words. He said the team was building around the wrong assumptions and warned that the current 2026 trajectory could compromise both reliability and driver trust. For a team that has fought its way back into contention, this is dangerous territory. The source of the tension? A series of simulator sessions using McLaren's 2026 prototype model, which according to internal leaks showed critical instability under braking and uncontrolled load variation in high-speed cornering. The new chassis, developed under the revised FIA regs, apparently failed to meet expected aerodynamic consistency. In some long-run simulations, Piastri's car showed tire overheating after just 5 laps, a scenario that engineers privately described as unacceptable at this stage of development. The data conflict didn't stop there. When cross-referenced with telemetry from real-world 2025 tests and extrapolated using McLaren's digital twin platform, the new 2026 model diverged from all expected aero maps. Under DRS deployment, the car generated asymmetrical rear load, meaning the car effectively became unbalanced at speed. That is not a setup issue. That's a fundamental design flaw, and the fact that it reached this point without being caught earlier is what has rattled the driver group. Behind the scenes, this sparked a heated internal debate. Some in the aerodynamics division insist the issue is calibration-related, not structural. Others, particularly in the simulator and vehicle dynamics group, argue that the entire aerofloor concept must be redesigned to comply with the FIA's new failsafe and flexibility thresholds. The problem is, there's no time. McLaren, like all teams, is racing against a frozen homologation window. Starting over now could mean missing key test deadlines or worse, launching a car that's legal but uncompetitive. Meanwhile, the FIA's new oversight model isn't helping. With real-time data auditing, McLaren can't afford to hide inconsistencies or run experimental setups without logging full compliance paths. This has created a climate of anxiety within the garage. Every system from energy deployment to actuator response time is now a liability if not fully documented. And for the drivers, this changes the tone completely. What used to be a development challenge is now a confidence crisis. This is not the kind of instability any team wants 12 months from a regulation reset. For McLaren, it's worse because their recent resurgence made them a dark horse contender for 2026. Now, with tension between drivers, management under pressure, and technical staff divided over fundamental design direction, the team is no longer chasing performance. It's chasing clarity, and the clock is running out. The numbers coming out of McLaren's simulator sessions have triggered real concern. According to sources close to the technical team, Piastri's long-run simulations in the 2026 car showed consistent rear-end instability under heavy braking, especially when DRS was engaged mid-corner. The result was unpredictable yaw behavior, the kind of balance issue that cannot be corrected with driver inputs or setup tweaks alone. These findings have forced the team to re-evaluate their current aerodynamic center of pressure, especially under variable load conditions. Even more alarming were the thermal maps generated during these runs. Within just 5 timed laps on race simulation pace, the rear tires were exceeding optimal temperature windows by as much as 12 degrees Celsius. This kind of heat imbalance not only degrades performance but also accelerates wear to dangerous levels. For a car designed under the new lightweight efficiency philosophy of 2026, such thermal inconsistency raises serious questions about cooling strategy and downforce consistency over a race stint. The brake-by-wire calibration data wasn't much better. One particular run revealed brake migration drift, a condition where the car's electronic braking balance changes over time due to Reagan input from the MGUK. In the new 2026 power unit configuration, where the FIA has reduced energy recovery thresholds and tightened mapping control, this becomes a high-risk problem. If not corrected, it could result in FIA compliance failures or even trigger unsafe on-track scenarios if the car's behavior becomes unpredictable into heavy braking zones. Suspension modeling revealed further complications. McLaren's 2026 concept features a stiffer front-end geometry to offset the reduced rear downforce caused by the narrower floor regulations. But in simulation, this setup produced a snap-oversteer profile in medium-speed directional changes, especially on circuits with elevation shifts like Spa and Suzuka. The data shows that when combined with high-energy input from the rear hybrid system, the car's balance shifts forward too aggressively, leaving little margin for error under trail braking. The aerodynamic department also flagged issues with the active aero response time. Under the revised 2026 rules, movable aero elements must include dual redundancy and response within a fixed time frame. In 2 separate sim runs, the system failed to deploy symmetrical adjustments within that margin. This lag creates both compliance risk and performance loss, especially in qualifying laps. More troubling is that the system passed static bench tests, meaning the issue may lie in real-world airflow simulation, not hardware or software design alone. Power unit integration has presented its own challenges. The 2026 architecture demands a compact hybrid unit with ultra-efficient thermal regulation. However, data shows McLaren's current layout struggles to keep the battery pack below the FIA's new peak tolerance. In one high-load simulation replicating a race restart, the system overheated after just 85 seconds of sustained deployment. This not only risks triggering thermal cutoff systems but also violates cooling response regulations, leading to possible homologation rejection. Finally, the core concern is that all of this is happening simultaneously. There's no single fix. The issues span across braking systems, aerodynamic stability, thermal control, and software compliance. Internally, engineers are calling it a cascading fault state, where one subsystem failure increases the load on others, accelerating degradation. For a team trying to meet the 2026 homologation deadline, this kind of convergence is not just inconvenient. It's potentially catastrophic. Inside McLaren's Woking facility, the atmosphere has shifted from cautious optimism to internal urgency. What began as an aggressive push toward 2026 competitiveness has become a relentless triage effort. Engineering teams are now spending more time analyzing faults than progressing with development. Multiple departments are working in parallel on fixes, but none of them are in sync. The result? Delays, contradictions in data, and missed simulation milestones. And as Piastri's camp has made clear, confidence is eroding fast. The powertrain group has taken the brunt of the blame internally. The MGUK mapping issue, where regenerative braking inconsistently offsets mechanical input, has required a full rewrite of the deployment algorithm. But because McLaren outsourced part of their software package to an external partner, the integration process has slowed. The control logic for energy deployment was designed months ago under the assumption that 2026 parameters would stay stable. Now that the FIA has redefined those limits, the existing structure no longer aligns with compliance or reliability. Meanwhile, the aerodynamics division is split over how to respond. Some engineers advocate a rapid redesign of the floor and rear bodywork to shift pressure balance and cooling flow. Others argue for waiting to collect more data from upcoming wind tunnel sessions before committing to major structural changes. But the clock is unforgiving. Each redesign triggers a cascade of effects, from wiring reroutes to actuator placement, all of which must be simulated again. And those simulations, right now, are returning more questions than answers. The chassis group is also under stress. The stiffness setup that's meant to satisfy FIA floor flex regulations has created new problems for tire wear and ride comfort. On circuits with elevation change, like Zandvoort or Interlagos, the simulated car is oscillating, a sign that suspension response time is out of phase with expected downforce loads. Fixing that requires a rethink of geometry, dampers, and mass distribution, but those choices must also align with the new energy recovery layout. It's engineering whack-a-mole. Perhaps the most unspoken tension lies between departments. There are growing reports of internal friction between the vehicle dynamics team and the simulation engineers. Each side believes the other's modeling tools are producing flawed outputs. That's created mistrust in decision-making, especially as deadlines for final CAD locking approach. With Mark Webber now involved as Piastri's advocate, management is under pressure to align fast or risk losing not just momentum, but internal unity. McLaren's top brass is aware of the situation. Team principal Andrea Stella has reportedly held a series of closed-door sessions with technical directors to streamline priorities. But when resources are limited, and systems are failing under pressure, compromise becomes painful. Do you fix the balance issue and live with overheating? Or repackage the cooling at the expense of aero flexibility? Every path forward comes with a sacrifice, and no one can guarantee which compromise is survivable under the FIA's brutal enforcement model. The situation is now binary: solve the integration crisis within the next 60 days or face the very real possibility of launching a 2026 car that is legal, but fundamentally flawed. And in modern Formula One, legality without performance is irrelevant. It's not enough to pass scrutineering. You have to finish races. You have to keep drivers confident. You have to deliver results that match the promise of your concept. Right now, McLaren is in danger of doing none of those things.